Hello guys, so today we are solving this question and first see by yourself and then solve and come to the solution. Okay, so it's a question based on op-amp and MOSFET in which we have to find out the current through this M1 current through this M1 MOSFET. Okay, current through this M1 MOSFET and determine the voltage across the resistor. So and we have to determine the voltage across this resistor. Yeah. So first, it's a pretty easy question. Like first, by seeing the circuit, this is an op amp, and we can see there is a negative feedback going to the op amp. If it's a negative feedback, we can consider virtual short, virtual short concept, because there is a negative feedback in the question, and by the virtual short, what it means that the positive voltage will appears on the negative terminal. So it's VR. So this node is also VR. Okay, and now, now a current will flow to this branch, which is VR by 40 kilo amps. This current flow to this branch. Let me denote this MOSFET is M2 and by this M3, and we can say the parameter is given. Parameter is given is this, and for NMOS the threshold voltage is 0.5, and for PMOS threshold voltage is 0.5. It's also same. This is also same for NMOS. So by applying virtual short concept, the VR voltage appears to this M1 node, and we can see that this current, let V R by 40 kilo amp current is denoted by I dash. This I dash current flow to this branch, so it will also flow to this MOSFET I dash, and we can see uh, M2 and M3. M2 and M3 drain and source voltages are same are same. So its drain is, sorry, gate and source voltage, not drain and source, gate and source voltage. Okay, gate and source voltages are same. So if gate and source voltage are same, so current is also same. If I dash is flowing in M2 MOSFET, so I dash is also flowing to M3 MOSFET, because if we assume all MOSFETs in saturation region, because it's nothing is mentioned in the question, so we will assume the all MOSFET are in saturation region. So if this I dash current flows into M2, the same current will flow into M3, because the source and drain voltage, gate voltage, source and gate voltage are same, because in saturation region the drain current will depend upon VGS voltage. This is the formula of VNCY W per W upon L VGS minus VTH whole square. So this is the formula in the saturation where it depends upon VGS. So VGS is same, so current in this MOSFET M3 and current in M2 MOSFET is also same. So if we can see, I dash is also flowing in M1 MOSFET. I dash I dash current I dash current is equals to I current. I dash is equals to I current, and I current flowing into M1 MOSFET. I current flows into M1 MOSFET. We will write this half mu C over X W over L and VGS. Here VGS, this is gate and this is what VGS is VR normally. And VTH is zero point 0.5 volt whole square. I will change my color. Okay. So an I dash is equals to VR by 40 kilo ampere. IDS is VR by 40 kilo ampere. Okay, and it is equals to half mu n C over x w upon L for n mos are given is 20 microampere. Uh, so it is given as 20 microampere per volt square. So we can put the values 200 microampere per volt square VR minus 0.5 whole square. It will cancel out. It will cancel out and okay. After solving this, okay. Now solve this and make it aside. Make take it to this side. VR is equals to 40 into 10 raised to the power 3 200 into 10 raised to the power minus 6 and open this square. VR square plus 0.25 minus VR amp per volt square ampere and the ampere per volt square. So this voltage and this voltage and this voltage is cancel out. This ampere and this ampere cancel out. So okay, after solving this voltage square, I am cancelling out the unit. This will cancel by this unit, and there is an ampere microampere current, and this is an resistance. So resistance goes to the resistance goes to this, and there is an ampere ampere unit ampere into ohm. So we get the volt. I'm just balancing the equation, balancing the dimensions. So we obtain the voltage. Now solve this, and we get a it's a 10 10 to the 3 10 to the square 1. Okay, so we get 4 VR square plus 0.25 minus VR. Now this is a quadratic equation. This is a quadratic equation, and by taking this for this side, we will attain this quadratic equation 1.25 r plus 0.25 whole square, and applying formula for quadratic to find the roots. Now find the roots by the quadratic formula. VR is equals to minus b square minus 4ac by 2a will achieve 1.25 plus minus 0.25 whole square minus 4 multiply 1 multiply 0.25 into 1. We will get the two values. If we consider the positive sign, then we get VR as 1 volt. If we consider the negative sign, we get 2.5 volt. Now, which voltage to consider? This voltage or this voltage? Then we assume something in starting like in saturation region. All MOSFETs are in saturation region. So, for in saturation, VGS must greater than VTH, and VDS is greater than VGS minus VTH. Okay, and if we consider this 0.25 volt, means these both both equations should be satisfied to be in a saturation region. And if we consider this 0.25 volt VR is 0.25 volt, and this sorry, this MOSFET in saturation. So this is the gate voltage for M1. Like how is this? Okay. Oh, sorry. Okay, this is VR. It's a gate voltage, and for the saturation, VR should greater than VTH, and VTH is 0.5 volt. And if we consider 0.25 volt, 0.25 volt is less than 0.5 volt. So we will not consider this. We will not consider this, as it will lead to triode region or cutoff region for the MOSFET. And we will consider this as it satisfies VGS minus VTS condition, because 1 volt is greater than 0.5 volt. Okay, so we solve this part to find the voltage across the resistor. And for question, first part, current. What is the current in the M1 MOSFET? So I dash current is equals to I current. If we find I dash current, then we automatically find I current. So find I dash current. I dash is equals to VR upon 40 kilo ohm, and VR we calculated. We find out that VR is 1 volt. 1 volt upon 40 kilo ohms, and we will get 25 microampere. So final answer is VR is 1 volt and I dash is 25 microampere. Thank you.